Hey guys, this is video 2 where we're going to go over topics for normal calculations. So it says Sam has determined the weight of unpeeled banana from his local store has a mean of 116. So it's A minus B over statistics. So our mean score and his standard deviation. Assuming the distribution is normal, the heaviest 30% of the banana weighs at least how much? Right, so this is, the mean is 116, and the standard deviation is 9. So that means there's 3 to the left and 3 to the right that are 9. So 16 plus 9, 116 plus 9 would be 125. Minus 9 would be 107. And so you kind of get a feel for, they're asking, what is the area under the curve for the heaviest 30%? So they're giving us this area to be 0.3. So we can use our table to find the area of, and the table A only gives the area to the left. So the area to the left has to be 70%, and we can look on our table A and find a z-score when the area under the curve is 0.7. Then what is our actual score? That's what we're solving, sir. So we can call that x. Our predicted, well, you'd predict knowing nothing that you'd get an average banana. So our predicted score is 116, and they gave us our standard deviation of 9. So we know this number z right off of table A. So let's go grab it. If you don't have one, you just open Google. Hopefully you have a formula sheet laying around. AP Stats formula sheet. Yeah, table A. I'm looking for my area to be 0.70. So it's not going to be on the first page, right? Because these are the areas when they're less than 50%. So 0.70 looks like I'm getting close here, about 0.52 or 0.53, somewhere in between there. So I could put 0.52 or 3. It doesn't matter. 0.52. Maybe you think 0.53. And so we're just going to use the Lynch swap. We're going to move that 9 up here. And we have x minus 116. So 9 times 0.52 is 4.68. And just, sorry, copy that down. If we add 116 on both sides, we get, this value is 120.68. Awesome. So our answer is D, round up to 121. Now we can also, let's say, work this backwards in our calculator or check our work. Great. So let's say you could kind of approximate this using your standard deviation and eliminate any number below 116. You knew it was going to be, this line would be above that, right? So eliminate these and then plug these in. So we can use our calculator. If we go to menu, stats, statistics, go down to distribution, and you could do an inverse normal calc. So this is probably how I would do it. I know I'm looking for the area under that curve to the left as 0.7. So we get a screen where it says area for your inverse normal. Our area is 0.7. Mu, they gave me in the problem, 116. Standard deviation they gave us was 9. So my calculator, actually, I don't even have to guess. My calculator gives the answer 120.72. So you notice by doing it by hand, you get a slightly different answer. Both situations, I'm going to get D. Okay, now let's jump to question 24, which is similar to this one. Question 24 states, the western lowland gorilla, whose main habitat is in Central Florida, has a mean and a standard deviation of 40. So a mean, western lowland gorilla, I'll just say W, of 275 and a standard deviation of 40. Okay. The capuchin monkey, whose main habitat is Brazil, in other words, has a mean, okay, so this monkey has a mean weight of 6 and a standard deviation of 1.1. Both distributions are approximately normal. If a particular gorilla, so I'll actually call this G for gorilla. If a particular gorilla is known to weigh 3, so this is heavy, right? It's heavy because the average one is 270. How would it compare to the monkey? Approximately how much would a capuchin monkey have to weigh to have the same standard weight? So it's going to have to be something heavier than 6. So we immediately can eliminate that. And then we need our calculations, right? So these guys, if they have the same standard weight, then EB statistics, then their Z's are equal. Essentially, they're saying one is actually the same as the other. So we're going to set them equal to it. So the actual weight of our gorilla is 345, and we'd predict a gorilla to weigh 275 over a standard deviation of 40. We're going to set that equal to, we don't know, our monkey, whatever that is, minus our predicted weight of a monkey would be 6 over the standard deviation 1.1. So now using our Lynch swap, I'm going to move this up here, right? So 345, take away 275 is 70. So 1.1 times 70 divided by 40 is equal to x minus 6. Okay, so I get 1.925 is equal to x minus 6. So I'm going to add 6 on both sides, and I get 7.925, which rounds to C. And that's our answer. Nice work, guys. Check out the next video for the next subject.